Hi everyone, welcome to my channel. Today I will discuss another problem, question number 15 in the ISS examination 2016. Consider the problem. Suppose x1, x2, etc. xn are independent standard normal random variables and tn is equal to summation I equal to 1 to n xi square. Consider the following. Statement 1. The distribution of Tn is chi-square with n degrees of freedom. Statement 2. The asymptotic distribution of root n into Tn by n minus 1 is normal distribution with the parameters 0 and sigma square for some sigma square greater than 0. Which of the above is or are true? Option A only, option A 1 only, option B 2 only, option C both 1 and 2, option D neither 1 nor 2. Now it is given that x1, x2, etc. xn follows standard normal random variables. We have to add a new variable is defined as Tn is equal to summation I equal to 1 to xi square. In the first statement we have to find the distribution of Tn, that is summation I equal to 1 to n xi square. We know that if xi follows standard normal distribution, then its square follows chi-square with 1 degrees of freedom for I equal to 1 to extra n. Here given that x1, x2, etc. xn are independent. So by the additive property of chi-square distribution, we can easily verify that summation I equal to 1 to n summation I equal to 1 to n xi square, which is equal to Tn, follows chi-square distribution with n degrees of freedom. So the first statement is true, that is the distribution of Tn is chi-square with n degrees of freedom. We have to find the asymptotic distribution of root n into Tn minus 1, root n into Tn by n minus 1. Let y is equal to root n into Tn divided by n minus 1. Then by central limit theorem, it follows normal distribution with the mean is equal to expectation of y and variance is equal to expectation of y asymptotically, that is as n tends to infinity. Here we have to find here y is equal to root n into Tn divided by n minus 1, which can be written as Tn by root n minus root n. So we have to find expectation of y, which is equal to expectation of Tn divided by root n minus root n, which is equal to, we know that for a chi-square distribution with n degrees of freedom, its expectation is n and its variance is given by 2n. So expectation of Tn by root n minus root n is equal to expectation of Tn is n. So we can replace expectation of Tn by n, which is equal to n by root n minus root n, which is equal to 0. Now we have to find out variance of y. Variance of y is equal to, we know that y is Tn by root n minus root n, which is equal to variance of Tn by root n minus root n, which is equal to variance of Tn divided by root n. Since variance of a constant is 0, which is equal to, we can take root n outside, then it becomes root n square, that is n, which is equal to 1 by n into variance of Tn. We know that variance of Tn is 2n, so which is equal to 2n divided by n, so which is equal to 2. So by central limit theorem, y follows normal distribution with the parameters 0 and 2, that is which is of the form normal distribution with the parameter 0 and sigma square. Here sigma square is equal to 2, which is greater than 0. So the second statement is the asymptotic distribution of root n into Tn by n minus 1 is n0 sigma square for some sigma square greater than 0 is true. So from the given statement, both statements are true. So option C, both 1 and 2 is the correct answer.